Welcome to the next lecture in electrical sciences. This is the first year EEE basic electrical course. In this lecture we will focus on the digital systems. The contents that we are going to cover under the digital systems are: first we will talk about a comparison of the analog versus digital system. Then we will discuss the binary number system. What are the binary arithmetic involved in the digital system? A little introduction of Boolean algebra and its importance and application in digital systems. What are the two De Morgan's laws and the digital logic gates? So these contents for the digital systems will be divided into three different video lectures. So it will have three different parts. In the first part we will cover the binary number system, then we will move to the Boolean algebra, and then we will discuss the logic gate. So let us start the first part where we are going to discuss about the binary number system. But before that, let us see what is the difference between the analog versus digital system. In the electronics, two important systems that we discuss is the analog system and the digital system. When we talk about the analog system, it is basically the natural phenomena that arise its own properties over a period of time. So the time is an important factor because whatever the signal or the response that we capture is with respect to the function of time t. Now the natural phenomena means whatever the temperature, pressure or any other natural characteristic of a device, whether it is a voltage or a current for electrical device, that we measure over a period of time, and it is the own property of that system that is known as the analog system. So we can take the example of a temperature, barometric pressure, the wind speed, the solar radiation. If these natural phenomena we are measuring over a period of time t, then that is the analog measurement. So we will have the devices which leads to the analog measurement devices which measure these physical quantities. So in terms of the graphical representation of these physical quantities, that is temperature, wind speed and pressure, over a time t, we can see that this is a continuous process of measurement for each and every instant of time t, and hence these are known as the analog system. So analog systems are basically the continuous signal representation system. You do not have a discontinuity and there is no time gap between the two very small instant of time. So it is a continuous process of the measurement. There is no discontinuity involved and there is no time gap involved. And you will be having infinite values within a range. Like for example, if we take a very small duration of the time t dt, then the number of samples present or the measurement present will be tending to infinity. Means lot of samples will be there within the time t, so that there is no discontinuity and the measurement is a continuous process. Like for example, if we take a sinusoidal wave like this, and if there is a gap of the sample measurement, so that is a discontinuous process, like this first sample and here we have the second sample. Now if these two regions is having many number of samples, then in that case that become a continuous process because you have the infinite number of samples present within this zone. So analog systems are those systems which are having a continuous signal representation. The main disadvantage of this analog system is that they are susceptible to the noise which are present in the environment or the various type of interference. Like for example, you may have electromagnetic interference which are due to the other measurement system like a communication system which are present in the close vicinity of the measurement where we are actually measuring any of the physical phenomena. Whereas when we talk about the digital system, we are generally interested in only two states. The states may be the on state or the state may be the off state. When we talk about the on state, it is basically we represent it with 1 and the off state is represented with 0. So it means the number 1 and 0 or the on and the off state are the two states which are sufficient to represent any digital system. Now let us think of an example of switching on or off the light. So either the light will be on or the light will be off. It means either it will be 1 or it will be 0. Or if you talk about the electricity that is driven at a constant voltage, that is 220 volt, and the charges are being transferred through the electric wire that is fluctuating, it can be an analog signal. Like whatever the charges are going through the transmission line and it is driven at a constant voltage, if for a particular duration of time t we are measuring that voltage or a current, that is the digital system. In the analog system it is continuous, but digital system lead to some samples which we are measuring. On and off switching is the same logic which is used to build any digital electronic circuit. So in the third part of this lecture series, where we are going to discuss the logic gates, which are the fundamental building block of any digital electronic system, there this on and off state is only one which is important. Means we are either dealing with one state or we are dealing with the zero state. So that is the main logic of the logic gates, which are the fundamental building block of any digital system. Hence, we have a limited set of discrete values, that is zeros and ones. We are not dealing with many values, but we are dealing with only the two values, that is a number of zeros and a number of ones. These are resistant to noise and interference, which was the main limitations of the analog system. In the analog system, which was susceptible to noise and other interferences, but the digital systems are basically resistant to that noise and interference. If you take many examples, whether it is a computers, smartphones or digital cameras, nowadays all electronic or electrical gadgets generally work on the digital phenomena. So the measurement are basically taken for some duration of time t. The next topic we will take what are the different components that are present in any digital electronic system. So the first basic component are the active component, which are basically the transistors and the diodes. These are the basic active component that are involved in any digital electronic system. When we talk about the diodes, they are basically the unidirectional current flow devices. So the diode is represented with a triangle, and you will be having the unidirectional flow of the current. The current can flow only from the anode to cathode, and the reverse direction of current is not possible. So this we have discussed in detail in our electronics lecture series, and we move forward from the application of the diodes in the digital electronics. Whereas when we talk about the transistors, the two basic important use of the transistor is to amplify the signal and for the switching operation. So we know that transistors are basically the bipolar junction transistors, famously said. So BJT, it will be having the emitter base and the collector region. So in this region you can have the either the amplifying of the signal or you can have the switching operation. So these diodes and transistors are basically the most active components of any digital electronics. When we talk about the passive components, they are basically the capacitors, resistors and inductors. We have discussed these very detailed in electronics as well as electrical chapters, where we have seen like the active components are the source basically, and the passive components are basically the either the energy storage device, whether it is the resistors or the capacitors, the capacitors or the inductors, and whether it is the dissipating elements. So dissipating elements are basically the resistors, where you will be having the power loss. So all the power loss are basically involved in the resistors. Capacitors and inductors are energy storage elements in the magnetic field and the electric field. So the energy storage element capacitors in the storing the energy in the electric field, whereas the inductors which store energy in the magnetic field, they are the passive elements, whereas the resistors are basically the dissipating energy elements which result in the power loss. The third important and the most important component of any digital system are the logic gates. They are the basic components of the digital circuit with one output and more than one input. So input can be more than one, but the output whatever we are getting is only one. So we'll get only one output at the of the logic gates. When we talk about the logic gates, the basic logic gates are basically the AND gate, OR gate and NOT gate. These we will discuss in detail in lecture number 3 of this series. The universal gates are basically the NAND gate and the NOR gate, and some special gates are also there which is known as the JOR gates or the NOR gates. Okay, so the logic gates which are basically divided into 3 names, that is the basic gate, universal gate and the special gates. These gates are basically the basic fundamental component for any digital circuits, and apart from that we will be having the active component and passive components which are present either for signal amplification, switching or the energy storage in the electric field and the magnetic field. We also have the battery and the switch along with the other components. So battery act as the energy storage which is converting the energy from chemical to electrical, whereas the switch basically controlled the flow of the electric current. There is a difference between this diode and the switch, as well as when we talk about the transistors. So switch are used basically to have the on and off operation, whereas diode are used so that reverse direction of the current do not flow, and transistors are also the switching operations which can control the time t of operation of the switching axis. Now what are the basic advantages of the digital system over the analog system? So there are numerous advantages where the digital systems gain advantage over the analog systems. When we talk about the accuracy, the precision, the noise immunity, and it is more flexible because it can handle various data types and can be reconfigured in different tasks. Hence, for all signal processing instrument nowadays, whether it is talking about the filtering or the modulation of the signal, there it is being done with the help of the digital systems. And the data can be stored easily because it can be copied and transmitted without having any losses. Also, some cases we need the reproduction of the signal back from the original disturbed signal, and the detection and the correction can also be easily done. And hence, the scalability can be easily achieved when a different range of the signal has to be transmitted, and it can be easily integrated many number of digital systems when the system is very complex. And this has become now the standardization of all systems which enable the interoperability and the compatibility. So the cost effectiveness, if we talk about, then it is more cost effective due to the various advancement nowadays coming up, and the efficiency and security wise also it is quite good and robust as compared to the analog system. Although there are some disadvantages of the digital system over the analog system, this is generally due to the signal loss which occur when from the quantization error and the signal loss. We have some complexity involved because often more complex systems we need to handle at a higher cost. The data conversion always require the analog to digital or digital to analog converter. Means sometime we have to use either convert the signal which is captured in analog and it has to be converted into digital form, and at the receiving end we can be converting the digital to analog. So that increase the complexity and the cost of the measuring system. When we talk about the processing delay, it introduced the processing delay due to the signal sampling and conversion. The data storage site typically require more storage space. So compared to the analog system, you will require the more space, and the bandwidth can demand higher because it is due to the limitation of the communication system. The resolutions are limited, bit resolution leading to quantization error in analog data. Other limitations which can talk about the cost of the component, the energy consumption, the signal distortion, the learning curve, because we have a steep learning curve here, the incompatibility in the digital technology with the analog legacy, the quantization noise. So although the digital systems have now overtaken the analog system, but still yes, some disadvantages are there. Now let us discuss our main topic of the first lecture, that is the binary number system. The number system basically are divided into four major types. When we measure any number, it can be measured into four basic major types. The decimal number systems are generally used, which are the base of 10. The binary number system are base of 2. The octal number system are the base of 8. And the hexadecimal number system are base 16. So day-to-day life, we then generally use the decimal number system, and this topic we will focus on the binary number system. In future, we will take the octal and hexadecimal when we will discuss the digital system in more detail. Now let us take the example to understand so that we can appreciate like how these number systems are different in different systems. Like for example, the decimal number system 245 can be written in binary form comprising of various 1 and the zeros. In the octal system, it is written as 365. So the number 245 has become 365. Somebody can argue that 245 somebody can say, and somebody can say the 365, both are the same numbers depending upon which number system we are operating. So if somebody is operating at a decimal number system base 10 and somebody is operating at octal number system base 8, both are giving the same output. And the hexadecimal system, we can write F5. So we can say that same numbers can be represented in different number system which are basically used for different devices. However, we will focus only on the binary number system now in this lecture. So binary number system are the number system using only two symbols. When we talk about zeros and ones, here we can see that the number 245 has been represented with the help of only zeros and the ones. And how this 245 has been converted to zeros and ones, that is basically the binary number conversion from this decimal to binary. The word binary is basically derived from the word bi, which is the first two letters, which basically means two, means we are basically operating with ones and zeros, which are the two binary numbers involved. So binary number system, each digit is basically called a bit. So if we see here in this number of 245, how many bits are involved? So this is only one bit, this is the second bit, third bit, fourth bit, fifth bit, and so on. So these are basically the digits which are involved, and talk about the bit system. So when we represent in the base 2 as the binary system, then we generally write like this. When we have a number in decimal number system 25 which has the base 10, can be represented as the number 11001 with the base 2. So this is basically the binary number system which is represented with zeros and ones. So 5 digits means 5 bits, and hence the number 25 base 10 can be represented with the digital system as this number. And how do we convert this? Let us try to understand. So if we have the digital number system 11001 with the base 2, then we can number this. This is at position 0, this is at position 1, this is position 2, this is at position 3, and this is at position 4. So the 1 will be multiplied with the position raised to the power 2, plus the second bit, that is 1, will be multiplied with the position raised to the power 2, and similarly we can add it and we will get the number 25 as the base 10. So the decimal number system 25 with the base 10 is equivalent with 11001 with the base 2 in the binary number system. If we see the numbers in the decimal number system and its corresponding binary representation, so 1 is basically represented at 001, 2 is represented at 010, so we can see that position of 1 has changed. The 3 is represented with 011, so there are 2 ones involved, and so on we can represent. Here we can see that when we have up to 7, the 3 bits are involved or 3 digits are involved. When we talk about from the digit number 8 to 15, if we take, then up to here we have the 4 digit or the 4 bit system, and 16 to 20 if we see, then we have 5 digit system. So the number of digits or the bits increased when the number increases. Now when we have the binary to decimal conversion, so we can see the number has been raised to the power 2 with its corresponding position multiplied with the number itself. If we can appreciate this with the help of one example, like we have 10011 base 2, then this is position 0, 1, 2, 3 and 4. So the 1 will be multiplied with the 4th power, that is the position of the second number, that is the 2, the binary number system. Similarly, the second digit or the bit we have 0 multiplied with 2 to the power 3 because 3 is basically its position. So in this way we can complete it and we can add to get the value 19. So this binary number system, its corresponding digital system is 19. Now similarly, if we convert the binary to decimal, we can convert the decimal to binary conversion, and this is being done by division rule. So divide the decimal number by 2 continuously until the quotient 1 appear. For example, if you have 28 as the decimal number, we have to divide the 28 with 2 and find out the reminders. So these are basically the reminders. When we divide 2 with 28, we get the remainder 0. When we divide the 2 with 14, we get the remainder 0, and so on. We keep on moving this division, and then we see what are the numbers appeared in the remainder list. So that are basically going from down to up. We are getting 11100 with the base 2. So we have converted the decimal to binary number system. The decimal number system will have the base 10. The binary number system will have the base 2. Now similar to decimal number operation, arithmetic operation, the binary numbers can also be added, it can be subtracted, it can be multiplied, or it can have the division process. So binary addition, binary subtraction, binary multiplication and binary division. Now if we add the binary numbers, it is basically addition of only two numbers, that is either 0 and 1, or it can be having 0 0, it can have 1 0, or it can have 1 1. These are the four possible combinations of the numbers. And when we add 0 0, it means to off state we are adding, we are getting the addition 0 and there is no carry forward, that is 0. When we are adding 0 and 1, we are getting the addition 1 with no carry forward, that is 0. When we are adding 1 plus 0, the similar 1 is appearing, no carry forward, 0. And if we are adding 1 plus 1, 1 plus 1 is equivalent to 0, addition with a carry forward of 1. So this addition can be taken with any components like a digital computers or digital logic pads, which take the addition as on state and the off state. When we talk about the subtraction, like for example two numbers involved 0 0, the subtraction will be 0 and there will be no borrow. So there it was a carry, now it becomes a borrow. If we subtract 0 minus 1, we will get 1 with no borrow, with a borrow of 1. If we have 1 minus 0, we will get 1 with no borrow, 0. 1 1 will give subtraction 0 with no borrow, 0. When we talk about the multiplication of the binary numbers, if two numbers 0 0 is multiplied, it gives to 0, 0 into 1 will give 0, 1 into 0 will give 0, and 1 into 1 will give 1. So if the number is only on and on, then only we get the multiplication 1, with all other possibilities will be 0. Whereas in the subtraction, we are getting only 1 1 when the first number has to be 1 1. then only we can get the subtraction 1. Now division, like generally when we convert the decimal numbers to binary numbers or binary to decimal, lot of division processes are involved. So suppose for example we are dividing a number 11011 with 11. How do we divide? So the division process is similar to what we take for the decimal number system. Like if we have 1 here, if the first quotient will be 1, so it will be 1 and then we do the subtraction with the binary number system. So similar process goes on, and hence the answer for the division is the quotient 1001. Similarly, if we divide 11010 with 101, and we can have this is the quotient and the final the remainder is 1 with appropriate subtraction rule and the division. Generally in binary number system there are two complements, which is 1s complement and 2s complement, that are being used in any digital electronics or computer science. So 1s complement and 2s complement are two methods which are used to represent the negative numbers in binary. So for example, suppose we have minus 1001 with base 2. So these negative number in binary number system are basically represented with the complement of 1s and 2s. First we see the 1s complement. 1s complement are found by simply flipping the numbers, changing the zeros to ones or ones to zeros, all the bits in the binary representation. So you are flipping the zeros to ones and ones to zeros. So it means if you have a number in binary number system comprising of 1 and zeros, this you have to find the 1s complement. You are basically flipping the zeros to ones and ones to zeros. It means the 0 has become 1 now. Similarly, the 1 has become 0 now. And this process goes on by flipping the binary representation. Whereas in the 2s complement of the binary system is little bit more complex to compute, and here the most common way to represent the negative number in binary. So generally we represent the 2s complement in binary number system. So it start again with the 1s complement only of the binary number system as calculated above. So first we have to go with the 1s complement system and do certain calculations like addition of 1 to the 1s complement result to get the 2s complement. Okay, so 1s complement which we already have got in the previous step. Now if we add 1 to the 1s complement here in the previous result, we will be getting this result. So the 2s complement is nothing but the way step forward from the 1s complement with converting, first changing the bits from 0 to 1 to 1 to zeros, and then addition of 1 to the previous 1s complement. So this complete the first part of the digital electronic system discussion for the first year basic electrical science course. In the next part we will go into the Boolean algebra, and the third part we will see the logic gates. Thank you for now.